Part 5. Exploring radical equations. As with solving linear equations, so something like x plus 3 equals 7, okay? Radical equations can also be solved with inverse operations. So what that means is, let's make that a 2x plus 3. If I were to get x by itself, I would first subtract the 3 from both sides, and then divide both sides by 2. Okay, so we can do the same thing with radicals. So if you're given a question that has x squared, then you want a square root. So if you have a question that has a square root, then you want to do the opposite, which is square it. Okay, so if you have x cubed, you'd cube root both sides. Same idea. So if you have the cube root of x, then you're going to cube both sides. Don't forget to state your restrictions. Example 1. State the restrictions and solve the equation and verify it. Remember, verify means to check that your answer actually works. Okay, so restrictions. We have an x plus 3. So that, of course, has to be positive. So we would say that x plus 3 has to be greater than or equal to 0. And again, it's in the numerator, so you have to make sure you don't have to worry about it not being able to be 0. Okay? And again, we would subtract 3 from both sides. So x would have to be greater than or equal to negative 3. So if I chose negative 4, for example, which is less, negative 4 plus 3 would equal negative 1, and we can't square root that negative 1, so everyone okay, I hope, with that x has to be greater than or equal to negative 3. Okay, now let's solve. So square root of x plus 3 over 2 equals 4. So to get rid of a square root, the opposite of square root is to square. But remember, whatever I do to one side, I have to do to the other, so I'm going to square both sides. That gets rid of the root sign, so x plus 3 over 2 equals 4 times 4 is 16. And now we can start to get x by itself. So I'm going to get rid of the divide by 2, and to do that, I will multiply both sides by 2. Okay, so the 2's cancel here. We're left with x plus 3 equals 16 times 2, which is 32. And then we're going to subtract 3 from both sides, so x equals 29. Okay, let's do a check. Sub back into the original question, so square root of x is 29, plus 3 divided by 2 equals 4. 29 plus 3 is 32, so that's the square root of 32 over 2. 32 divided by 2 is 16, so the square root of 16 equals 4, and we know that, of course, to be true, so we did that one right. Good job, us. Next one, state the restrictions and solve the equation. Verify the solution. Well, because we're cube rooting, we know that there are no restrictions on the variable. It can be either positive or negative. Because it's all in the numerator, we know that x minus 1 can, x in that case can still be, it's still not restricted because we're not dividing by x. So let's put that there are no restrictions. Okay, so cube root of x minus 1 equals 3. So to get rid of a cube root, we are going to cube. Now remember, we have to cube both sides. Okay, so the cube root of x minus 1 cubed just leaves us with x minus 1. 3 cubed is 27. We're going to add 1 to both sides, and x equals 28. Let's do a check. X equals 28. So into the original equation, in place of x, we're going to put 28. Carry away there. And equals 3. Okay, 28 take away 1 is 27, so that becomes cube root of 27 equals 3. And the cube root of 27 luckily is 3, so we have this one right as well. Remember, if the answer does not work when substituted back into the original question, your work may be wrong, or your answer is what's called an extraneous root. We'll see some examples of that in our next section. For now, you can just go to work on page 215, all questions.